Where is it in this one?
Name is the same. So it's updated on the website.
Right, well that was an exciting way to start. Alright, only 23 minutes late. I guess Kahoot goes out the window. Sorry about that. That was a bit of an exciting way to start this lecture with nothing working. I did try to rip off this door off the hinges, so clearly that was the sign of things to come. Okay, so welcome. Happy Valentine's Day. What a way to spend it. Doing coding, how exciting. And now you get to hear me rant about this awful keyboard as well. So lucky you guys, lucky you guys. And if there's anything about computing people, it's keyboards. Everyone can't stand bad keyboards. The number of times I get asked if you can bring in your own keyboard into the exam, I'd retire by now if I could have $1 for each time someone asked me that. All right, so on Monday, we had a really exciting lecture where we kind of did our welcome, all the boring stuff, all the admin stuff, and we talked about how 1511 works and what we do in 1511, all the best ways to get help. Now, some of you have also now gone to your first tute and lab, so you would have gotten a lot of help in those tutes and labs. It's also probably the time where we've lulled you into this nice false sense of security. You all printed out your hello worlds and you think this is going to be great. I'm going to ace this class. That is fantastic. Sorry, it's going to get a lot harder. And the labs are going to get a lot longer with a lot more exercises. We're really just trying to ease you into things. So today we're going to talk about variables. We're going to talk about how we store variables and how we store information. And then we're going to also talk about some constants. And then we're going to talk about how we do maths in C and all the weird and wonderful things. Can I move my camera to the other side? I don't know what I can do anymore. I couldn't rip the cupboard off the hinges, which I really wanted to do. Great, there we go. Like that. Is that better? Okay, there was not much to see for those online. It was really not that exciting. This camera is also not following me, it's just looking over there. So you get to see that blue thing. I don't even know what that is, so that's exciting. So that's going to be our plan for today. Okay, the code will be in the same place. We'll do a little brief recap. Actually, can we start with a little poll of how is everyone feeling today? And if everyone is feeling good about our beautiful hello world, or if you want me to go over this piece of code again, the brief recap of what we did on Monday. I keep warning you, it's a steep learning curve, it's a steep learning curve. Just remember that when it gets to week 3. Oh, you've done it. Oh, and I can see it on this computer. Okay. Oh, 100% are doing great. That feels like not a fair, oh, 1 vote. That's not good. That person's doing great. Everyone else, not sure. Still just 1 person voting. Okay. I think it's because everyone's in the wrong stream. All right, I'm just going to go over it whilst we wait for that poll. Okay, so when we did our little piece of code on Monday, we talked about what a comment is. A comment is for human eyes, and it basically describes what your little program is doing. It's for another human to read. When a compiler compiles your program, it does not care about your comments. It does not read them. So it is really just for humans. And you do a comment with 2 backslashes, or if you want to do a longer comment, you do it with a backslash asterisk, an asterisk backslash to finish it off. And we'll do a few of those today. Then on line 7, we've got our include line, and that line is the line that includes the standard C library. And what that means is it allows us to basically print something out to terminal. And today we're going to learn how to take something from terminal as well. to make our computer programs a little bit more exciting. So it's not just always the same data that you've decided it's going to be. So that is both in stdio.h, the standard input-output library, and we're going to learn more about libraries in week 3, so don't worry about that. We then have our main code, our main function, and you will always have a main in C. It is so that we know where to start the execution process, so you will always start inside main, even if your main is on line 100. It will look for the main and start reading into the code there. We talked a little bit about kind of the syntax, but I didn't want to go into too much detail so as not to kind of freak everyone out, because we haven't really learned what a function is, what is returning, and what is everything else. So for now, just remember the syntax, this sort of int main, brackets, void, and then you've got your curly braces, and inside the curly braces we're going to write our code or our instructions that we want to execute. So the printf function is inside that standard input-output library, which means I don't need to know how it actually does the code. I just need to know that I need to use it every time I want to print something out to my screen. And in this case, we printed out welcome to COMP1511, exclamation mark, and we put it in double inverted commas. And then this beautiful thing at the end here, the \n, that allowed us to have a new line. So it allowed the text to have a new line so that it looks much nicer as well. And that's how we can do new lines when we print something out. And then in C, we finish each line with kind of a semicolon, and we'll talk more about that as well as we go. And then I said, for now, just remember that return 0 is just a piece of syntax as well, the way we finish some of these functions. We'll talk about when we don't need to finish a function with a return. But for now, the 0 just means that the program was executed successfully, nothing's happened, and that's why we'll return 0, kind of standard practice to do that. Okay, fantastic. So that was our lovely program that we wrote on Monday, and we're going to do a little bit more today. I'm going to be using a VLab on a browser, and if you log into that, you'll see it'll tell you to please not do that. So please don't do that. I'm only using it because this computer will not let me download Tiger VNC or VS Code or anything to actually be able to do the coding, which is why I'm using something that's not particularly safe to use. So you guys don't do it. Don't do as I do. Do as I say. So how does a computer remember things? Who knows? Who knows all about computer memory? Does anyone know anything exciting about computer memory? Yeah.
Well, so the CPU interacts directly with random access memory or RAM in order to operate an object.
Okay, so you're going to give me a detailed answer. I love that. Okay. All right, so we've got this. Yeah, go on, Sophia. Just over there at the, Sophia, you will not make that throw. I mean, why even attempt that?
Oh, sorry.
It gives me joy to see you throw. I don't know why. All right, so basically it's, you don't need to really know this, but I always think, otherwise other things don't make as much sense. So I like to talk about it very briefly. Computer memory is basically a big pile of on and off switches. And these little on and off switches, they're ones and zeros. They're little bits. And it's a bit, it's the smallest possible unit in computing, and it's a choice between a 0 and a 1. So it's either a 0 or it's a 1. And that's why it's the binary notation, because there's two choices, 0 or 1. Now we often collect these bits together, and we do them in bunches of 8 bits, and we call those 8 bits bytes. And that kind of forms your little chunks of memory that you will store things in. So, well, this is too big and it doesn't give you the full picture. All right. So basically, when you execute code, the CPU will process the instructions. It will perform the basic arithmetic. And then your RAM, your random access memory, will keep track of all the data that you need to process those instructions. And so there is kind of two bits of things that we'll touch in this course in 1511. We'll kind of touch the memory that's located in the stack and the memory that's located in the heap in the second part of the term. But in this first part, we will only be touching the stack, and that means that it's controlled not by us, okay? And that means we don't have to worry much about anything. It's controlled by not us. The heap is controlled by the developer, and that's when we touch memory, and that's when it becomes, I don't know, a lot more fun, but a lot less pleasant. There's no really other way to put it. Okay, so one way of asking the computer to remember something for us is to use something called a variable. And the reason it's called a variable is because it varies and it can change its value. And depending on what kind of variable it is, we need a certain number of bits that we will use to represent it. And each time, each different data type of variable, it will have a different number of memory that it requires. So we make that variable with a specific purpose in mind. That means if I know I'm going to do some maths, I'm probably going to use the data types that allow me to do maths with. I'm not going to use strings, although I shouldn't really talk about strings yet. So we're going to start out with 3 data types today. We're going to start out with an int, and that's an integer, a whole number, so you can have negative and positive numbers. We're going to talk about a char today, which is a single character. So it's more than just the alphabet, and we're going to talk about why that is as well. And then we're going to talk about something called a double, which for all intents and purposes is just a decimal value. And it's a floating point number, called floating point because the decimal point can float about, but hopefully not whilst you're kind of doing your calculations. And each of these has a different number of bytes that are allocated to it once the program is run. So let's talk a little bit about naming those variables before we actually start to write some code and use those variables. So I've kind of started before. We had this file called cheese.c, which was an awful name. I said it's not a great name because in a few months' time you'll go back to it, you'll have no idea what that was about. The same thing goes for your variables, okay? You have to pretend at each stage of the game that another human is going to come and look at your code. If you call something X, Y, Z, it's not really clear what they stand for because you might have quite a few variables going in one program. So the one important thing is we want to name it, we want to name our variables as something that makes sense or something that actually gives value. Someone who's reading our program, another human, will be able to read through it and kind of know what we're doing from the names of the variables. So it has to be a quick description of what a variable is. So answer or diameter or whatever it is instead of X or Y. We always use lowercase letters to start our variable names. And in C, the variable names are case sensitive, which means that lowercase letters to uppercase letters, they don't, it's not the same thing. They're two different variables. And we also can't use those words that are reserved. So things like return, we can't use it because it's a special word in C. We can't use int, we can't use double because those are also special things in C. So we have to be careful what we use. And then in this course, in our style guide for multiple words, if you want to name your variable 2 words, then you will use snake case. And that means you'll write in small letters whatever the first word is, and you'll put a little underscore, and then you'll write the second word. So you are basically naming it based on what's going on. So we want to have it to be obvious what we are representing. So we do have a style guide in 1511, and if you're ever in doubt about what you should do, or if you're ever in doubt about how you should name something or how you should structure your code and style your code, this is where you will look. Because in your assignment 1, in your assignment 2, you will be marked on your style, because there is nothing worse than getting bad habits to start with and then someone having to read your code in a few months' time. And in industry, we used to do code reviews, and sometimes I used to look at someone else's code and think, I don't know how you got through uni, this code is awful, I actually don't know what on earth is happening here. So be nice with your code, write it nicely. You know how like in school you were always probably told, if we can't read your handwriting, we're not going to mark it, similar thing. Even though you're typing, sometimes it's unreadable, the code. And I will show some examples of unreadable code later on as well. Okay, so let's talk about the very first data type. So the first data type is an integer, int. It is a whole number, which means no fractions, no decimals, and it most commonly uses 32 bits, which is also 4 bytes. Now, is that guaranteed? Does anyone know the answer to that? Is it guaranteed that it will always be 32 bits? I'm going to let someone else take a guess. It's a binary answer, yes or no? What do you reckon? Guaranteed or not? Yes or no? No, it's not guaranteed. And it really depends on which computer is compiling and what the computer is doing. So little embedded systems will often be 16 bits, and then you might have a 64-bit computer and it might compile it as a 60. So you cannot guarantee the number of bits. There are ways to do it in C that you can guarantee that it will be 32 bits. You will use a slightly different variable, but in this course we're not going to care about it. It's just going to be an int. So we're going to assume in this course that it's 32 bits, even though it's not always the case. And that gives us exactly 2 to the power of 32 different possible values. So the maximum is large, but it's not infinite. It doesn't go to infinity and beyond. So the exact range is going to be minus 2 to the 31 to 2 to the 31 minus 1. Why is there that minus 1 at the end? What do you reckon? Pardon? Something else. Yeah, and what's in the middle? That is, everyone always forgets. Yeah, 0 as well. Yeah. Oh, Sophia, what a beautiful throw. You made it. That was the easiest one. So the point here is that there is an ending, right? It's not infinite. You can't. And we have had a lot of issues from that as well. It's not, and I've included some examples of those issues of integer overflows. There are some really, really fun ones. Should I talk about them now? I feel like I should. It kind of belongs here. All right, I'll go down and talk about them now because it feels like I should. Wow, I really went crazy and included them a lot later on. Okay, so we had a plane that had to be rebooted every 248 days because it was 2 to the power 31 hundredths of a second. And that was a software bug causing an integer overflow. There was also the Ariane 5 explosion, and it was another simple problem in where 2 large ints were added together, and it kind of overflowed and rolled back to the minimum and potentially ended up negative. Right, so it's not clear what happened, but that was an issue that kind of led to a disaster because it caused an explosion. Less destructive example, Gangnam Style actually broke YouTube. They'd never expected the counter to keep going, and the counter kind of got stuck at the maximum possible number, and it maxed it out, so they had to kind of change what's going on there. So there's a few examples of this kind of thing happening, these integer overflows. It's not really, and it's not uncommon, which is a little bit sad. Happens quite often. All right, character data types. Another exciting data type. A single character in C can also be represented as an int. So good luck. Not confusing at all. And that's because a single character holds an ASCII value. Okay, so in C, well, not in C, in Terminal, you can bring up the ASCII table and you will use it, you will bring it up. You don't have to remember what values each letter stands for or what each one stands for. But if you type in ASCII, and I've got this -D here for the reason that it cuts out the hexadecimal values, it just gives me the decimal values so it's easier to see. It gives you the values of all 127 ASCII characters. So in C, if I want to store the character for little a, that's also going to have the value 97 in it, okay? Because 97 is the value of little a, and 65 is the value of big A. But you can see over here, there's a whole bunch of weird things over here as well. And this one is my favorite, but I can't make it happen because I'm logged into a remote machine. But that 7 bell, it does a little ding on the computer, which is always very exciting. And there's a few other ones, right? So number 10, who knows what LF stands for? Who said that? Who said line feed? Yeah, line feed, which just means on a typewriter, I've gone onto the next line. So it's still called a line feed. It's the same as doing that \n. And you will kind of use that because, you know, you'll be able to see that sometimes you're swallowing a character that's not a letter. So in C, the syntax to assign a single character is to put that character in single quotes. So as soon as you do these little quotes, the single ones, it means that it's an ASCII value, right? So for a capital letter A, the character is using these little A's, and then the int associated with it is 65. And basically you can, you know, have fun with the chars, and we will try assigning them, and we'll see what happens in each one as we do it. And then the last of the data types that we'll talk about today is a double. And a double is a decimal, so it's a floating point number. The point can be anywhere in that number. It's called a double because it's 64 bits, which is double of an int, which is 32 bits. So not, you know, not creative naming of things. It's really just exactly what they are. And it's a decimal place, and we will look at today how to display that decimal place in different ways as well. All right, let's do some code, finally. It always feels boring until you get to the code. Yeah. Oh, my head's in the way. Not the first. It's not even my head. It's just like a fraction of my body. There we go. Now you can see my head. All right. So far we've got these exciting things that are just hello worlds. Let's do one that's going to be, that have something to do with variables. Okay, let me rearrange it a little bit. Okay, so first things first, let's do some variables. So first I'll put a comment in. I hate this keyboard, I really, really do. It just doesn't work well with my nails, this keyboard. Okay, so first thing, I'm going to still include my standard input-output. You will see me make a lot of typos. Okay, and then we're going to start our main function. So let's do our int main. All right, so that's just going to give us a little shell of what's going on. And now let's see how we can play around with this shell as well. All right, so let's do an int first. Why not? Okay, so there is two things that you have to do when you're going to use a variable in C, and that is I have to let someone know that I'm going to use it. So I'm going to declare that I'm going to use it. I'm declaring it. And then I might want to assign a value to it. And I really should assign a value to it, because otherwise why do I have this variable unless I'm going to do something with it? So let's look at it, and there's a few things we'll do here. So let's first declare a variable. So to declare a variable, you're going to say what kind of variable you're doing, which means the type. And the type of variable can be an int, and in your case an int, a char, or a, so first state what type of variable, int, double, or char. And then I'm going to name that variable. So I've said that it's going to be of type int. So now we know how much memory this variable will require when we compile the program. So I know how much memory to set aside for this variable. Well, not me, I don't care. The computer knows how much memory this variable needs. And let's call this variable, I don't know, number. And then you put a little semicolon. So what that has done is that has declared that you're going to have a variable of type int. Beautiful. I feel like that was perfect timing for that as well. The music was a bit, it could have been more exciting, I feel like, for what we've just done. We've declared our first variable. And then I need to assign a value to it. So to assign a value, I'm going to say number, an equal sign, and I'm going to give it a number. Okay, so in C, this one equal sign means that I'm assigning something to a variable. So I'm going to place the number 13 into the variable number. Okay, this looks all very exciting. 2 lines of code. Now I can actually do this in 1 line also. I can say what type of variable I'm doing. Let's say I'm doing a variable int, and I can assign it straight away some sort of value. Okay, I don't need to do 2 lines, I can. And when you first start programming, often it is actually easier to do things in more lines than you require because you're doing things step by step and you're still learning how to skip steps. So feel free to do whichever way works for you when you're first starting out as well. So now we've got 2 variables. How exciting. We've got 2 variables. They're both ints. Why don't we print them out so that we can see what actually happens? So I'm going to print out, oh, I should have probably said how to print them out. Okay, the variable number is, and now I don't know what to do because I don't know how to print out a variable. How do I tell that print statement that I need to insert a number in there? Whatever number that variable holds inside it right now, I want to print it out. So you've got these things called, why are you smiling like that? Are you excited?
I'm very excited.
Sophia's excited. Okay, we've got these things called format specifiers. And I'm jumping ahead a few slides, no one. You don't need to know the names for these things. I'm always obsessed with finding the correct name for something. I don't know why. But what they are is they're little placeholders, right? They're little things that tell the computer, oh, I want to placehold something in there and I'm going to tell it what it's going to be. So if I want to do that, and you'll see, okay, you will see me in lectures making a lot of comments throughout the code. Don't do that in your code. No one wants to look at your code with 1,000 comments in it. The reason I'm making these comments is so that when you are learning and going back to it, you can read over it and it's like lecture notes. But when you're doing your code, don't put so many comments. You don't need to say declare a variable, this is a variable. It should be obvious from what from what you're writing and from the names of your variables. Okay, if I want to print out a value that is inside a variable, I will use a format specifier. And I've got a few types available to me. So for now, let's focus on the first one that will give us an int. If I do that percentage and a D after it, that will give me an int. Okay, so what that means is I want to placehold and I want to insert an integer in this statement. Okay, so I would then place %D, and I'm going to do a new line just so that it looks pretty. Now, if I have written something like this, okay, what am I missing now? What do you think? I've told it I want a placeholder. I want to put some sort of variable in it. What haven't I told that statement? Yeah.
You haven't told it what variable you have.
Exactly. I need to tell it what I actually want to put in there. Otherwise, I've really left it hanging. It's so unfair. So what I'm going to do is going to put a comma and I'm going to name the variable that I want to go in there. And I want the variable number to go in there. And then I'm going to just close my bracket, my semicolon, and this is a beautiful statement that will now hopefully print stuff out for us. So let's see what it does. Okay, let's compile. What did I call it? Variables.c. Oh, I see. So what's the error there? I can't spell is the error there. Okay, so you can see that it's compiled it, but it's given me a little warning, and the warning is unused variable number 2. All that it's saying is I've got this other variable number 2 here. I haven't done anything with it, so what's the point of it? It's redundant. I'm going to ignore that because I will use it later on, but it means that I can run my code. So I'm going to run it, and the variable number is 13, which it is in fact 13. That's the number that I've put in here. So that's a bit exciting. Let's see if we can do the same thing for our second variable. So the second variable we've declared and initialized it. So we've declared and initialized in one line. And now we're going to print it out. So I'm going to use the format specify again, %d, I'm going to do a new line afterwards, and then I'm going to put a comma and I'm going to write which variable I wanted to have in there. Okay, let's see now, save that and see how that compiles and if we get that written out. So I'll recompile it. I said I hate this keyboard. I wasn't joking. I think one time tried to rip it out of this thing and okay, let's try this again. Here we go. So it's compiled it beautifully. So now let's run it and it's going to print out two statements. The first statement over here, the variable number is blah 13 and that's what our first variable was. And then the second variable, number 2, is blah, which is what the second one I set it to print out. Now I don't have to do it all in these 2 lines. I can do as many format specifiers as I want in that printf statement as well. So I could print out both of them at the same time if I wanted to. So I can say it's %d, and then I can also say number 2, or number 2 is, and I can do another %d. And then what I would do is I would just list the variables in corresponding order. So I've got my variable number here. That's the first one that I want seen. So I'll do number first. And number 2 is here, so I want it to come second. All right, so now I've done them both in one line. And I can do that as well. Let's hope I haven't made any spelling mistakes. I have again. Exactly the same spelling mistake as before. Okay, so compile it and I'm going to run it and now it's printing out both of the variables. So I can have as many as I want on there. No one cares as long as I give specific instructions what I want. All right, well that's ints, and ints are pretty amazing. They're pretty wonderful things. So now let's look at chars, which are always for some reason quite tricky, and I think the tricky thing about them is really that they're a number as well as a letter, which doesn't seem to really work that well in our minds. It's like when I was learning how to drive a manual car and my dad told me my head does not agree with my feet. It's the same thing for the ASCII. So if I type in ASCII and then I do -d, what you'll get is the ASCII table, okay? You don't need to know all the ASCII values. You will probably know a few in week 3, and then you'll forget them just as well. So all you're doing is, it's just for you to see what's going on, and then we're going to play around now with it. So I'll bring you back to what values they hold, just to show you what I've said. So if we are to declare a char, so let's declare a char now, and initialize it. Okay? Same thing, to declare a variable, I'm going to first say what type of variable it is because that lets the computer know how much memory to reserve for it. I want it to be a char, and then I'm going to say the name of the variable. and I'm going to be really amazing with this name, call it character, and then I want to assign a character to it. Okay, I'm going to use little single quotes, and then I'm going to put a little letter S. Okay, so that over here declared and initialized a char, and that means that inside a variable called character is sitting this letter S. It also means that it is stored as number 115. And I'll show you how we know that. So if I do a printf statement, oh, we've only learned one format specifier. We've only learned the D. So I'm going to use a D. Why not? And then we're going to learn how to do one for char. Okay, and so I'm literally saying, give me a number for this character because I'm saying it as a %D, and %D means number. So let's compile it again. I actually can't. Someone else has to type printf for me. This is ridiculous. Clearly the T offends me today. Okay, let's try it again and let's run it now. So down here, you'll see that the variable character is 115, which is the ASCII value of the letter S, okay? So it is stored as that number as well as the character. You can go between the two of them. Because I've done it in those single quotation marks, that's what said that it's an ASCII character. Look, I know this is all very exciting, but if you do feel the need to kind of party about this character, you might need to step outside just so that everyone else can hear, even though I do have quite a loud voice. Okay, so let's do a format specifier for a character now to see it written as a letter. And what do you think it's going to be? Just take a guess. Percent what? Yes, very good. %C. Excellent. And then I will tell it. I could have just written it on the same line as well, but I've written printf with a T, so I felt very proud of that. So let's compile it and let's run it again and let's see what it does. Aha! So the variable character is 115 and it's also the letter S. Now what that means is you can really do maths with characters, right? Because they're just numbers. So you can subtract them, you can add them, you can do whatever you like. Well, not whatever you like, calm down. It's not, you know, I don't know how much you need to do with characters, but you will need to do a few things in a few lab exercises. And just know for now that they're both int, char, all kind of not the same, but the same. Okay, so we've got one more data type left, one more variable type left, and it is a double, a decimal point. So let's do a declare a okay, so to declare again, same thing. First off, you do the type, and the type is going to be double, and that's going to say I want a whole bunch of bits for it. I want double the bits of an int. I want a lot of memory space for it, and then I'm going to name it something, and I'm going to call it a decimal. And I'm going to assign a value to it by using that 1 equals sign. So 1 equals sign will mean that I want to assign a value to it. And the value is going to be, I don't know. Okay, just because I can't. Okay, 3.14. How amazing. Okay, so now let's try printing it. Nope. Nope, nope, nope. There we go. Okay. You will never guess the format specifier for a decimal value. A D? What's that one? An F? Almost. Close-ish. Yeah, what did you say there? Yeah, an LF. Okay, we're going to print it out as an LF. Okay, so %LF will give you a decimal value. Just remember it as a long float. That's what it stands for. And I want to pop the value of decimal in there. Okay, printf is spelled correctly, I know because I fixed it, so let's clear that. Nope. All right, compile, and Let's run it. Let's see what's going on. Okay, the decimal is 3.140000. Okay, that's looking a little bit meh. It added me a whole bunch of zeros. Maybe I want to shorten it and just write it as 3.14. Ideas on how I would do that? Any guesses? Yeah, is it a guess or do you know? Oh, you know, okay. Are there any guesses? Yeah? Pardon? Yeah. Okay, that's pretty good. I could, yeah. I want it to 2 decimal places. Okay, let's see what that does. Ah, very good. It's done it to 2 decimal places. So that's the way to kind of cut and trim your decimals to however many decimal points. You'll see some of the weird things that happen with that as well. You've got an exercise in your lab coming for that. And we are also going to do a few weird and wonderful things that will show you that there are some weird and wonderful things and see that kind of really hit the precision of the numbers that we're using. Okay, so that's our decimal value. And you can mix these statements up. I can have a %D, a %LF, %C. I can have anything in one statement that I want and as many as I want in there as well. Okay, so that's not really, you can do whatever you like. You're the boss. You tell the computer what instructions you want it to follow and you write the code for them. All right, so I think that was pretty good. Let's take a 5-minute break and then we're going to do the math stuff with it as well. So let's let these variables soak in. All right. All right, so let's keep going so we can get through everything today for this week, which is super exciting. So now that we've got all this exciting stuff, we can print out a lot of things. We've got variables now. Now we want to read something in so that we can actually take a variable from terminal and do something with it, as opposed to just having these stagnant variables that I have to specify in my code and that's it. I can take something from the user and then do something fun with it. Okay, so I feel like maybe I'll go to the code. Yes, I feel like I will go to the code. Okay, so let's go in the same. Is it getting confusing to work in the same file? Would you rather I break off into another file, or are you happy for me to go in the same one? All right, I'm going to go in the same one. Okay, so let's scan something in from the terminal. So to scan something in, you saw that we have this command printf, and printf is the one that prints out to terminal. Similarly, in that standard input-output library, we have a command that lets us read something from the terminal. So it lets us take a variable from a user. And that command is that function that will read stuff in is called scanf, okay? Now, scanf is pretty amazing. It has some weird things about it as well. We will not talk about why it's weird. We'll talk about a few things why it makes it weird, but not all of it. You'll probably not use scanf that much as you kind of leave here, but it's a good function to get an understanding of some of the weird things that happen in memory later on. But for now, what we're going to do is we're really just going to kind of learn the syntax for it, and that will be that. I don't expect you to then understand it yet, because we haven't really touched memory yet. Okay, so to scan something in, we're going to use the following syntax. Actually, I need a variable. Let's start with an int, because it's an easiest variable. So I'm going to declare an int, and the int is going to be called, I don't know, answer, why not? And you'll see I'm not going to initialize it for now, because I'm going to initialize it inside my scanf statement, which means that I'm going to take a number from the terminal, and that's what I'm going to use to initialize that variable. So I'm going to use the scanf function, and what I'm going to do is I'm going to need to tell it what to scan in, what type it's scanning in, and the same %d or %c or %lf, so the same format specifiers that you have in printf, also work inside scanf. So if I want to scan in an int, I'm going to tell it that a %d is coming, and then I've got to tell it where to put that %d that is going to scan from the terminal. So it's going to take a number, and I need to tell it where to put it. So I guess when you're thinking about it, maybe kind of logical sense, you would, okay, I want to put it inside answer and call it a day, which is nice. Not going to work, okay? Because what scanf does is it needs a memory address of where it's going to put it. You don't need to remember it right now, but just know that the next thing I do is calling for that. So that little ampersand in front of the variable name is basically telling it to go to the memory address of answer and store it in there, okay? So that is just the syntax of scanf. You don't need to understand it yet. In week 5, you will learn to understand what it actually means and how it actually works. So why don't we try it? We'll scan something in. You won't know if it's worked because I'm not printing it out, but why not? Let's just try. Actually, we should probably know if it's worked or not. So what I'm going to do is I'm going to use a printf statement directly afterwards, and I'm going to say the number scanned in, and that's just to see what it is that we scanned in potentially. So I'm going to do that, and I'm going to ask it to print out whatever is inside that answer, which is hopefully the number that we're going to scan in. So let's save that, and let's compile, and then let's run it. I should have probably done a prompt, not very good usability. So you can see that it's kind of hanging there, and that's because it's waiting for my input because I haven't actually given it the term. But I'm going to input the number 42, and then it's going to print it out. So it's taken it in, it's put it inside answer, and it's given me the number scanned in is 42. So if you wanted to make it nicer, you could just write here, you know, type in a number to scan in or something like that, right? So that it's not just sitting there, no one knows what it's doing. So if you do that and then run it again with the spelling mistake, I know it's there. I'm going to have nightmares tonight, just T's chasing me. And brackets, brackets and T's. Forgot a semicolon. You'll be hunting for those semicolons come assignment time. All right, so now it's asking me for a number to scan in, 42, and yep, it's working. It's scanning in 42. Amazing, amazing, amazing. I could be quite annoying and do two numbers as well. So let's say I have answer 2, and I can ask it to type in 2 numbers to scan in, and I can tell it that there is 2 numbers coming, and you can place them again corresponding, one into that answer and the second one into the second answer, okay? And I can do the same thing here, and I can say second one.
Oh, there's a missing semicolon.
There's a
missing semicolon. That's 2. That's 2.
Where is it?
Oh, int and 2.
Thank you. I've got my own semicolon hunters now. I don't need to do it myself. Thank you. Okay, and then the numbers scanned in, and then I can actually just say what they are. And let's have the second one. Okay, so let's save that and see what it does. And then we'll try it with other variable types as well. Okay, type 2 numbers, so I can say 42 and 43, and it's scanned in 42, and because I randomly did a new line and a comma randomly, because why not, you don't have to be able to read this, then it's done that. I've literally told it to do it in that horrible way to display it. So I've got no one to blame but myself for that. There we go, that will make it look prettier. So you can scan in a number of numbers as well, and it, you know, you can do whatever you like. Almost, not quite, but all right. Let's try scanning in a decimal, shall we? So before I scan something in, I need to create a variable to store it in. So let's do. So I've declared a variable. The variable is of type double, which means it's going to store a decimal, and the name of it is decimal answer. Okay, so now I'm going to scan in to initialize it. So I'm going to scanf, and maybe before that I'm going to print out. Okay, so then I'm going to scan it in. So I'm going to need to tell it what's coming, and what's coming is a LF. Okay, so I'm going to tell it an LF is coming, and I'm going to tell it where to store it. So I'm going to do the ampersand to say where to go, and then I'm going to name the variable that it's going to go into, which in this case is decimal answer. And then I want to know, because in this case I want to know that it's scanned in the right thing, so I'm going to output it as well so that I know that it's doing the right thing.
Missing a semicolon. Yeah.
So many semicolon hunters, thank you. All right. Good job. I don't know if I'm saying that to myself or to you. Everyone, good job. All right, so let's see what happens. Oh, this is going to get annoying. Now a decimal, and it's giving me the decimal, right? So the scanf is doing the decimal as well, no problem. All right, you know what I'm going to do? I'm going to encase everything so that it's not printing out all of this stuff. I'm going to encase it in a big comment, okay? So that we can kind of not have all this ridiculous exit. And then we can kind of start afresh over here. So I'm going to give it a comment. And now I'm going to do a character scan in. Okay, so same thing for a character. If I want to scan in a character, I've got to first have a variable to store it into. So I'm going to declare a character by declaring that it's of type char. I know, now you can take things from terminal, print them out. Now your life is changing before your eyes, and all on a Wednesday afternoon. And let's call it character answer. Just really going here with this same sort of style. Great, and now I'm going to scan something in. Okay, so let's scan in. Same thing, and I'm getting really excited because %C is really weird in scanf, so I can't wait for it to go wrong. And I'm going to scan it in the same way. I'm going to say and I'm going to give it character answer, semicolon, and oh, I guess I have to print it out as well with a T, and okay, new line, and it's going to be, okay, fantastic. Let's see what happens. Oh, I haven't, okay, yep. Oh, how awkward. There you go. You should be able to view it now. Okay, what's this for? Variables. Okay, DCC. Actually, I'm just going to, there we go. Let's compile it. And let's run it. Let's see what happens. Okay, it's waiting for me to type something in. Okay, I'm going to type something in, and it's going to say the character is A. How amazing. I mean, how can I make it go funny? Yeah.
I have a question.
Sure.
Is there a way to like scan a specific amount of decimal places?
What a great question. What do you reckon? What do you reckon?
I believe we just put in the like the usual printf.
You can. And then what do you think, what would be the repercussions of, because you don't know what the user's going to do, and the users are unpredictable. So you're better off taking it all in, and then you can, when you're printing it out, you can restrict the number of decimal places. But I mean, the question might ask for something different, and we can play around with that. Oh, the question was, can we scan in something with a certain number of decimal places? I need an official shusha as well. Thanks, gang. Okay, so how can I break this? How can I make it not take in a character? What do you reckon? What will I do? Yeah.
Type in a character that's not on the ASCII. Sorry.
Oh, absolutely. That would break it. I could type in a character that's not on an ASCII table, and it would not know what to do with itself. It would not, it would just over there. It was over there on the edge. Good throw. Okay, I could do that. That would absolutely wreck chaos. What happens if I just press enter? Okay, that's not, I mean, it's doing it. Enter is a character. Enter is wonderful. Yeah? What if I type in 2 characters? What would it do? I don't know. It's just going to read in the first character and ignore everything else. It really is. How else can I break it? Yeah. What happens if I do a number? Okay, let's do number 5.
Press enter. Just press enter.
Yeah, so I did press enter over here and it read it in because number 10, line feed. Yeah. I mean, I could. I could do that. Yeah. If I do a space bar, what happens then? Ah, thank you. Thank you very much. That deserved a Kit Kat because this is what I was trying to show. Okay, good. Ah, what is happening here? Okay. So sometimes, because a space bar is still a character, right? A space is still a character, and it needs something to tell it that I would like to ignore the preceding white space before you start scanning in a character. And I can do that. And the magical way to do it is to put a space between that %C and the double quotation marks. And it will stop doing that. It will ignore the preceding white space, basically. So if I recompile it now with that little change, and I run it, and now I press space, and now I press space. Okay, so it's still doing that. But when I type in H, it's going to ignore that white space rubbish, and it's going to just read in the character. Yeah. We can still break it. How else could you break it?
Do a non-Latin character.
Do a non...
Latin character.
Yeah, I don't know how to do that on this keyboard.
Is it possible we could just press Control-C on the terminal?
Yeah, you can. It will break out of whatever you're doing. Yeah. Yeah. Hang on, I can't hear you. So other data, that's a great question. The question was for those online, does the space thing work for other data types? So an int ignores space. It does not care about space because space can't be a character. It can't be an int. But because space can be a character, it doesn't ignore it, if that makes sense. So, but it ignores it for integers and decimals because they're a particular data type that do not include spaces. Okay, what about a negative number? No one said negative number. How are you going there? Sorry, I'm making you jump up and down. Okay, good. That's the gym today. Okay, so for the negative, it just took in that first character, and that's because I think it's on the ASCII table. The little dash. Is the little dash on the ASCII table? Well, it should be if it's done that. Yeah. So it's done it because there it is. It's 45. It's a character. It took it in. Okay. So that's why characters are a bit funny because it's taking it from the ASCII table. Okay, so that's your characters, which is just so exciting, okay? So now you've got 3 types that you can read in, you can put out to the terminal, and that gives you just some wonderful things that you can do. Oh, constants, that's what I was doing next. Okay, all right. What happens if I want to have a constant in my code? What is a constant to start with? What do we reckon a constant is? Yeah. Yeah, something that never changes. It remains constant. Okay? Like Sophia not improving the throwing. That seems to remain constant. So sometimes in our code, we're going to use something that's not a variable. It doesn't vary throughout the program. We know for certain before we start our code that this value will never ever change. What are some examples of those types of values? Yeah.
Speed of light.
Speed of light, never going to change. I mean, unless we make, I don't know, some sort of bizarre discoveries. Yeah. Value of pi, it's not going to change. Anyone else? Yeah. Yeah, that's right. So any of those types of things, they're not going to change. They're going to remain constants. So to do constants, we're going to go outside of our main. And we're going to define them in here by using the keyword #define. So we're going to use the keyword #define, and then we're going to have our constant. So the one thing about constants, okay, is that we like for them to be in capital letters, okay? And the reason for that, and that's part of really your style, if I am as another human reading your code, anything that I see in capital letters, I will know straight away it's a constant, which helps me to understand what's going on in your code, whether something will change its value, whether it will stay the same. And so anything in your code, when you're writing your code, anything that doesn't change value, it's very good practice to define it as a constant, because it's much more readable for another person when they're looking at your code. All right, so outside of our main, which means we define them out here, oh my God, it's not happening today with the T's. Okay, define constants outside of the main. We're going to use #define as our keyword. Let's do pi to start with. So I'm going to give the name of it. So #define is the keyword that I'm about to define a constant. Then the name of that constant, in this case pi, and then what value I'm giving that constant. 3.14, done, okay? So if we want to use it now, I could use it to do some maths. I could use it to print stuff out. I could use it to, let's do it in maths. Oh, but that means we should do maths. We should do maths. Okay. No, I'm jumping ahead. Which way did I want to do it here? Oh, I was already doing scanf. I'm killing you here. I'm killing you with information. I don't want to do that yet. Okay, I'm gonna break out of that loop. Okay, so let's talk about some maths, and then we're going to use those constants within a maths environment, just to, I don't know, for fun. Okay, so in C you can do add, subtract, divide, multiply, which is nice. Those are all the things that we kind of want to do if we're doing basic maths. Add and subtract, pretty self-explanatory. Multiply, pretty self-explanatory. And then we get to divide. Divide, not as self-explanatory. Divide is quite weird. So I think let's first play around with add and subtract just to see it in action. So I think I'll just remove that from here so we can have two numbers. So I've got 13 and 42, and then I'm going to call it a day over here. I'm going to start my comment here and kind of hide all of this away. Okay, so we've now got two variables. Let's try and do some things with them. 13 and 42. Amazing. Okay, so we can add them together. Okay. If I add them together, I can do it in two ways. If I do it just on its own line, I will need another variable to store whatever's happening into the result of that addition into. So let's say I'm going to do an answer, and I'm going to initialize that answer. So I've declared a variable called answer of type int, and I'm going to assign to it the value of the sum of those two numbers. So I'm going to say that it's going to be equal to number plus number 2. And then I'm going to print it out to show you that it does in fact work. I'm not lying to you. So the sum of %d and d is, what a sentence. And it's going to be number 2, and answer. Okay, let's try that. Okay, compile it and run it. And I've got two variables. Amazing, it added them together. That seems to have worked all right. Fantastic. Okay, I can also subtract them, and that's still going to do nice things. Okay, that's not going to break it. Okay, so it's given me an answer to that, minus 29. That didn't break it. I can multiply them. So if I want to multiply them, I'm going to do this wonderful thing. Okay, let's see it give a product. Okay, and it's given a product. I'm going to trust that's correct. Okay, great. So we've done, you can do add, you can do subtract. You can also do them in 2 lines if you want. I don't have to do it all in 1 line. I can declare this. So I can declare a 3rd variable and then I can initialize it. So I can do it like that if that makes more sense. But let's be lazy because computing people are usually lazy and do it all in one. What I can also do, if I'm feeling particularly lazy, I don't need a 3rd variable here. What I can do is I can literally write my expression that I wanted to output in here. So all I'm saying is that this, oh, and I've forgotten the first 2. So I'm telling it that for the first one, first %D, I want number, second %D, I want number 2, and for the third %D, I want the product. Okay, so I can do that as well. So if I run it again, it's going to do the same thing. It doesn't care, right? So you can do it in that way as well, and that means you've saved yourself some memory, not that you're using up that much memory with an int variable. Okay, let's have a look at division, because division can be a little bit weird. Okay, I'm going to not use the numbers 13 and 42 because the numbers are going to get, I want to demonstrate something that's, let's do 6 and 3 to start with. Okay, and to do division, we use a fraction bar. Okay, so what do you reckon happens? I mean, not much because 3 goes into 6, so hopefully nothing happens and it gives me the answer. I would hope that it's smart enough to do that, and it is. What happens if it doesn't go into it nicely? What happens if it's 6 divided by 4? Error. Did someone say error? Okay, it's not that stupid. It rounds. You reckon it rounds? What do you reckon it rounds to? Down, up, somewhere? Okay, it's going to say that it's 1, okay? And that's because it's not actually rounding, it's just not giving me any remainders, right? Who knows how I can get a remainder out of it? I mean, if I make it a double, it will do something, but it might do weird and wonderful things depending how else everything else looks. Yes, okay. So there is something called a modulus, okay? And the lovely modulus is something that gives us the remainder. Okay, the modulus is a percent, a lot of percent for you today, percent everywhere. And what the modulus does is it provides, it's going to give the same thing because I haven't compiled it. It provides the remainder, okay? So if I divide 6 into 4, I'm going to get 1 remainder 2. And if I've used the modulus symbol, it's just going to give me the answer as 2. The modulus symbol is really useful for checking if something is even, or because I can check that, when you divide it by 2, is it going to give me modulus 0? There has to be no remainders, and a whole bunch of other things, but that's one of the more common ones that you will use. I know, even more exciting. Now you're doing maths on top of coding. It just doesn't get any better than that. All right, so now we're going to talk about this, maybe some doubles, maybe some ints. Let's see what happens if what I've done is I have said, okay, I've got 2 ints here. Int number is 6, int number 2 is 4. What happens if I divide them? And what you said, the answer, I would like for it to be a decimal. What do you think it's going to do? When I divide these two numbers, what do you think is the answer going to be? 6 divided by 4. I've told it I want the answer as a decimal. What do you reckon it's going to be? Everyone's too scared to guess. They know they're going to get it wrong. Yeah. Very good. Well done. Okay, so what happened is there's an integer being divided by an integer, and I'm saying, well, I want the answer to be a decimal, but it's actually, it's not that bright, okay? It's just going to give me the answer. I forgot to save it, so it didn't demonstrate, it didn't have the big moment that I wanted. Let's try that again, pretend like I wasn't explaining. Okay, so now it's going to tell me, hey, hold on a second. You've kind of got the wrong, well, thanks DCC, it's giving away my big surprise, but it's saying, right, you should probably have a %d here because you're dividing two integers. You can't really have an answer that's going to be a decimal from that. So what I'm going to do is I'm going to ignore that warning. Don't do that at home. This is something, don't try this at home. It's going to give me a whole bunch of rubbish. And then it's going to just say, no, no, thank you. Okay, I'm not going to do that for you. So, okay, and for a different reason than what I was hoping, I've created a whole mess here because I've been writing all in one main, which is something you shouldn't do. Okay, so when you divide two ints, the answer you're going to get is an int. What happens if you divide two doubles? Let's have a look at that. What do you reckon happens if you divide two doubles? You get a double. Okay, let's have a look. So I've got two doubles. This is going to complain now. I'm going to change this, not LG, LF. And let's do this one as well. And these ones. And this one. All right, so now I've got two doubles dividing each other, and I'm telling them that the answer is also going to be a double. So now what it's going to do is it's going to give me something that doesn't look that nice, but it's going to give me the actual decimal division for it. Okay? Now what happens if I try to divide, I don't know, 1 divided by 3, and then store it in an LF? What do you reckon is going to happen? Yeah, it's going to keep truncating. So if you're going to keep using a never-ending fraction, what's going to happen is your error is going to keep growing and growing and growing. Okay? So you're not going to get a lot of good maths out of it, right? Because you're going to keep building on top of an error. Okay, so in C, also the order operations, it works the same as it does everywhere else in maths. So you can use brackets to say what to do first. And that's quite exciting, I guess. So you know, you're not kind of doing anything exciting, you know, and new. But what I was saying before, characters are also numbers, which means we can do maths on characters as well. So let's do some maths on characters. Okay. So let's take in this character, okay, over here. This character is S. That's not what I wanted to do. Where's the scanner? Oh, it's later on down. All right, let's have a character S, and let's say what I want to do is I want to print out something that's 2 after it, okay? So what I can do is I can say, okay, I'm going to print out a character that's 2 after it. What do you think it's going to print in this case? Who knows the alphabet? Yeah? Okay. What have I done now? Wait for it. It's too much experimenting. Didn't like me. I mean, if you've ever been rejected, this is the best way to get rejected. Just disconnect it, that's it, it's all over. And on Valentine's Day as well, I've got to complain. And this is why you should never use this internet browser. All right, okay, oh good, at least it saved it. So here's something, let's see how it goes. Don't worry, there's not long to go. Okay, so it's giving me an error for something a lot further up, what have I done? Oh, I've got this statement here, which is, let's just comment that out, because that statement, this is what happens when you randomly change things without any kind of goals in mind. Okay, and somewhere I've forgotten a comment. Living my best life right now. Line 63. Beautiful. Erroneous. That's why you can never be neat. All right, there we go. Let's try this again. Didn't mean to do that. And let's try running it. I haven't run it before, that's why. All right, and it's moved the character 2 spaces, and it's given me that the character is you. And all I've done is added 2. Okay, so I can do maths with characters as well, which is just, hopefully your mind is blown. I can also add 2 characters together as well if I want. You know, what happens if I add, I don't know, A and B? What do you reckon I get? Might help to see the ASCII table. You might not get anything. What happens if I add number 1 and a big A? What do you reckon? Yeah? What? 114? Yes. Okay, I was like, but depending how you put, I chose a really bad example, because if that 1 is in little single quotation marks, then you'll get 114 because it will go to the ASCII value of it. Okay, I feel like everyone has had enough of variables. Is that what we're feeling? Okay, so, last thing, okay? If you felt completely lost this lecture, or if you felt it was too easy, or if you felt anything at all, and you would like to let me know, please feel free to do so. I take feedback from every lecture, and then I pace the next lecture accordingly. I hope you have a lovely Wednesday, and I'll see you all next week. Good luck for your labs.